Okay, we have talked about properties a little bit. Like we, had little conversations, but we're going to blow it out of the water today. Okay. And so I'm going to start with one thing I want you to understand at the end of this lesson is that you can apply properties to generate equivalent expressions and then identify when two expressions are equivalent. Okay. And so, kind of like our flow chart when with the coordinate plane, this right here shows you examples of these properties. Okay, so when in doubt, I would refer to this. Okay, but let's talk about the wording. Excuse me. So the commutative properties of addition and multiplication state that if all operations are addition, or all operations are multiplication, the order does not matter. Okay, meaning, look right here. 7 times 2 is 14. But if I change the order of my integers, 2 times 7 is also 14. So order doesn't matter. Over here, 5 plus 1 is 6. Well, 1 plus 5 is 6. So either way, order doesn't matter. Okay? Now, the associative properties of addition and multiplication state that if all operations are addition or are all multiplication, the way the values are grouped does not matter. Okay? So when you have to identify properties, what I've always told students, associative property, okay, addition and multiplication. When you're identifying the property, the first thing you want to do is ask yourself, is it addition? Is it all addition? Or is it all multiplication? And if it is, because you will see grouping symbols, the parentheses, I want you to look at your variables or integers in this particular example, okay? So associative, the first 4 letters of associative, ASSO, I came up with, that's like an acronym for all, stay, same, order. Okay? Same thing with multiplication. All, stay, same, order. Okay? So your numbers stay in the same order, 2, 3, 4, 2, 3, 4, 3, 4, 5, 3, 4, 5, which mean, but all we change is the parentheses. Okay, so all stay same order. Okay, so the identity property of addition states that the sum of a number and 0 is itself. So over here, 9 plus 0 is 9. And then the identity property of multiplication states that the product of a number and 1 is itself. And then it's over here. So anything times 1 is itself. And then the distributive property, which we used a little bit, remember with greatest common factor, states that to multiply a sum hang on. Yep. So distributive over here. To multiply a sum or a difference by a number, multiply each term inside, sorry, there's a bug over there, inside the parentheses by the number outside the parentheses. Okay? So then, so what they're saying here is they want you to rewrite each expression using the properties above it. I'll give you like one example. For example, 2 times 7 times 4. I'm going to use the commutative property here. So I'm going to say CP for commutative property, and I'm going to do 2 times 4 times 7, okay? Because we're multiplying. And when you change the order of your numbers, you still get the same product. This one right here, I'm also going to call it the commutative property. This one's of addition, and this one is multiplication. So, no colons. This is multiplication. This one's addition. So 10 plus 5 plus 14. I'm going to say 14 plus 5 plus 10. So it doesn't matter what order I put my digits in, it's all going to be the same sum. Excuse me. And this one is associative. And here's why, because you might get this confused with the distributive property, but there is an operation symbol here. Remember, when we see an example of distributive, there would be no operation symbol. So 3 multiplied by, and then I have 7 times 8. So I'm just going to rewrite, okay, because this is all stay same order, associative property, and then move my parentheses. And the same thing over here. So rewrite, and then just move your parentheses, just like that. So let's talk about this right here. Rewrite each expression using the distributive property. So here's my I do. This is how I like to do it, and I really need you to do this. It's a very great strategy. It's wonderful. Hang on. Finishing my breakfast. Okay. So, let's look at this. I start, we'll see right here, distributive, remember, there's no operation symbol between your integer and your parentheses. I'm going to draw an arrow and point to the 4 and the 7. So in the distributive property is multiply your outside number by your inside number. So 4 times 7 is 28. Okay. Bring down the operation symbol inside your parentheses. Then multiply your outside number by the second inside number. That's blurry, sorry. And you get 36. Now we're going to simplify 28 plus 36. Okay, so 28 plus 36 is 64. Now let's look at another example right here. Now we have a variable. Well, we don't know what x equals. So watch what I do. Still doing the same thing, multiplying my outside number by my first inside term. Okay? So this is 10x. So 6 times 10 is 60. But you continue to bring your x down. Okay? Bring down that operation symbol, subtraction, and then 6 times 8 is 48. Now hear me out. We talked about in our algebraic expression, our last notes, these are 2 separate terms, but you cannot simplify anymore because we do not know the value of x. So this is as simplified as it can be. You need to do the you-dos on your own. Now, I hope you have a calculator for these next ones. Do not be afraid of decimals and fractions because these are rational numbers and we've been working with them all year. Same thing. 5/10 times 4. So in my calculator, 0.5 times 4 and I get 2. Okay? And I bring that x down plus 5/10 times 10. It's 5. Now at this point, you cannot simplify anymore because I do not know the value of x, and that's as simplified as it goes. So let's look at this we do. 1/3 times 9x. So I'm going to put in my fraction, ND, okay, numerator over denominator. 1 for my numerator, and then push your arrow down. That'll take you down to the bottom. And then 3. Push your arrow to the right. Then you can do the rest, times 9, which is 3. So I have 3. Bring down your x. Bring over your operation symbol, and then multiply. 1/3 times 6. So ND, 1/3, arrow over, times 6. And you get 2. Now again, that's as far as you can simplify because I do not know my value for x. Do you do this on your own? Okay. So we're going to kind of be putting some of this together using our properties and what we know about writing expressions. So Heather and 2 friends go to the fair. First of all, how many people is that? Yeah, 3. So remember that. Each person spends $25 on a ride pass and $12 on food. Write an expression that can be used to determine the total amount spent altogether and solve. So how many people went? So we're going to say 3 people. 3 people went, okay? Each person spends $25 on the pass and $12 on food. So let's say 3 people times $12 plus $25. Because $12 was food, and then they spent additional $25 in the pass, and that was 3 people. So it would be like saying 12 plus 25 plus 12 plus 25 plus 12 plus 25. But we're writing it with a distributive property to demonstrate how we're simplifying it, if you will. Now, it says write an expression that can be used, and that's what we've done, and solve it. So you could do one of 2 things. The first thing you could do, because we know order of operations, is find the sum inside of parentheses, which would be 37, and carry this down. So you could say 3 times 37, okay, which is $111. Or you could use the distributive property right here, and you could do 3 times 12, which is 36, plus 3 times 25, which is 75. And then, of course, when you add 36 and 75, you should get $111. So that is another way of using our properties. So you could do it this way and simplify like order of operations, or you could use the distributive property and do the same thing. Either one would be correct. And then you need to do the you do on your own if you're not with us, and show me when you're done.